Hello, my name is Rob Reynolds. Welcome to Calculus Section 3.8, Implicit Differentiation. And the first thing we need to talk about is the difference between implicit equation and explicit equation. Explicit is a little bit easier because it's already solved for y. If it's an implicit differentiation, it means that, or if it's an implicit equation, then it means that it's not solved for y. And I would encourage you not to go ahead and solve for y because it would be a mess. Meaning we would get negative x squared plus 1, and you'd have to take the square root of both sides, and that's how they got down here after you took the square root. Remember, you end up with two answers, not only the positive but the negative. And then we're left with taking the derivative, and it's possible, but there's a much easier way. And so that's what this lesson's about, is implicit differentiation. So we're still finding the line, the tangent line, or interested in writing the equations of lines that are tangent through a given point. It's just our functions now may not be functions anymore because this doesn't even pass the vertical line test, but they might be relationships. So our first example is a circle with a radius of 1, and it says calculate the derivative for this implicit equation. So similar to the last video that we had when we talked about the chain rule, when you take the derivative, I'll just remind you real quick, of e to the x, you do get e to the x. But when you take the derivative of e to the u, you actually get e to the u, and then it's times du, which technically sometimes we write it as e to the u du dx, or sometimes we just get lazy and just write it as u prime. But they all mean the same thing, either du dx, or u prime. And you may say, well, why didn't you do that for this example up here? And I'm going to say, well, actually, you can. It just is a dx, which nobody ever writes because dx divided by dx is just 1. So we're going to follow this. We're going to take it with respect to x. That's what this says. Take the derivative of y with respect to x. And what that means is, yeah, we're going to end up with a bunch of dx and dx's every time you take the derivative of an x. But when you take the derivative of, in fact, let's do it. So the derivative of x squared is 2x. Now, if you want to write the dx, you can, but of course, dx divided by dx is 1, and that's a waste of everyone's time and lead. So let's take the derivative now of this guy, which is the chain rule, 2y, y prime, or you could write dy dx. So either y prime or dy dx, and then don't forget to take the derivative of this side. This is an equation. You can do whatever you want as long as you do it to both sides. But they say calculate and find dy dx. Well, there it is. Dy dx is that guy. Well, let's solve for that guy. So 2y dy dx is negative 2x. And of course, dy dx turns out, if I divide both sides by 2, it turns out to be what? Negative x over y. So I'm done with part A. Looks like part B wants you to find the slope at this x and y point. Well, that's going to be easy because remember, this is the derivative is the slope. So the slope for 1/2 the square root of 3 over 2, all I have to do is plug it into this slope formula. So negative 1/2 divided by the square root of 3 over 2, which is negative 1/2 times the reciprocal. And you could leave it 1 over the square root of 3, or some of you know that as, if you rationalize the denominator, the square root of 3 over 3. And then you repeat the process for this one, and I think it's the same answer. It's just the opposite. Let's see what the author says. Sure enough, yay, negative, and then the opposite of the negative would be the positive. So again, here's a visual representation. You have a circle, and you found the slope at these 2 points. Example number 2. This time you have a trig function on the left and some more. So, oh, and it looks like a little product rule in here. So let's do the chain rule. The derivative of the outside, so the first thing you do is the derivative of sine, and hopefully by now you have memorized the derivative of sine as cosine. Write down the inside, and then times the derivative of the inside. So but I would just write, let's do it. The derivative of that inside is 1 d2. Well, when you take the derivative of y, you end up with dy dx. I'll just write y prime this time because it says find y prime, but that is the same thing as dy dx. So 1 d2 plus 2 d1. Well, the derivative of x is just 1. So the derivative of the outside, right down the outside. So the end equals, oh, now I need to take the derivative of this side, 2x plus, and what's the derivative of y? You guessed it, y prime. The derivative of y is the derivative of y. So be careful. I have students sometimes to tell me the derivative of y is 1. Well, you're right, it is a 1, but then it's 1 dy dx because you're taking the derivative of y with respect to x. But instead of writing dy dx, we'll just write y prime. So now you can see I've got a y prime on the left and a y prime on the right, and you have to work your algebra magic to try to get all the y primes on the same side and factor it out. I think the easiest way to do that is to distribute. So xy prime, the cosine of xy, plus y times the cosine of xy is equal to 2x plus y prime. So now I'm going to keep this pink term over here. I'm going to bring this pink term over, and I'm just going to switch sides on a bunch of stuff. So xy prime cosine xy. I'm going to subtract off this guy. So minus, whoops, sorry, minus y prime. And then I'm going to bring this guy over here. So I'll end up with 2x minus y cosine xy. And now I can factor out a y prime and divide by what's left. So the final answer, this stays in the numerator. And my y prime would be whatever's left when I factor this guy out. Well, that would be x cosine xy. And then when you factor out a y prime, I think that turns out to be a 1. Let's see if the author agrees. It's kind of a complicated answer. Yeah, x cosine xy minus 1. X cosine, yeah, looks like it. 2y, or 2x minus y. Yep, looks pretty good to me. All right, let's try example number 3. The derivative of the left is 2x plus, well, we just did this in the last problem. You have to do the product rule. 1 d2 plus 2 d1. I don't know if you want to spend the time to write those. Oh, no, wait, that's not a, oh, let's say it'd be helpful if I did it right. 1 doesn't say take the derivative of it. It just, I should have just written down 1 d2 plus 2 d1. Okay, so all of that yellow is, there's the derivative of the yellow. Now minus 3y squared y prime is that du equals 0. Because remember, you need to take the derivative of 7, and the derivative of 7 is 0. We're taking the derivative of both sides. So it looks like all my y primes are already on the same side, so I will do a couple things at the same time. I'm going to throw this on the other side. Oh, jeez, I think I can throw that on the other side and end up with a negative 2x minus y. And I'm going to factor out a y prime all at the same time. So from this guy and this guy, I'm left with x minus 3y squared. And hopefully the author, well, what's going on over here? Is this really, yes, it is. It's 2x minus y. And x minus 3y squared. You know, a little trick is whenever you see these 3 negatives floating around, I can multiply the top by -1 and the bottom. I don't know if the author will do that, but it sure does seem to clean things up a little bit nicer. I'm going to do it, and then I'll flip these terms around, 3x minus y. So I just distributed the negative to every term. And then, so I would say this would be the derivative, and then before we check, we just want to find it at the point 3, 2. So sometimes you write it at the point 3, 2. So evaluate it at the point 3, 2, and let's do it. So I'll plug in 2 times 3 plus 2 over 3 times the y value squared minus the x value. And if you number crunch that, I think you get 8/9. We'll see what the author says. Let's see. Oh, good. Oh, evidently we were supposed to even go a little bit further and write the equation of the line. Maybe I should read the directions. Find the equation of the line. So let's go one more step further. Y is equal to 8/9 x plus b. I'm going to plug in, this is my x, this is my y. So 2 equals 8/9 times 3 plus b. Oh, fun. So this is 24/9. And if I change this to a 9, that's 18/9 plus b. So I'm going to subtract off 24/9 and end up with b is equal to negative 6/9, and that reduces to negative 2/3. Let's see if that's the b value. Yay, negative 2/3. So there's the equation of the line that's tangent to this curve. Okay, I can't skip this problem because something happens that will happen on your tests and you need to recognize it when it does. And oftentimes, not always, but oftentimes when you do a second derivative, you can do a back substitution problem. So I'll see if I can show you what I mean by that. So the derivative here is 2x plus 2y y prime equals 0. So 2y y prime equals negative 2x, and then y prime would equal that negative x over y. That looks similar. But now we need to go find the second derivative. And here's where this backs up. I got to do low d high minus high d low all over low squared. Now, there's that back sub. That y prime is that guy right there. So we're going to plug him in. That's the back substitution, and try to clean it up, the second derivative. So negative y plus x times negative x over y, if I did that right, over y squared. I'm wondering if I could get a common denominator and just simplify this a little bit more. So I'm going to multiply by y over y and end up with, well, since they're both negatives, I pull a negative out and make it y squared plus x squared, all divided by y, but it's also divided by y squared, so I have a total of y divided by y cubed. Did you know that? If you have like 5 divided by 2 and then divide the whole thing by 3, that's the same thing as 5 divided by 2 times 3, which is just 5, 6. So if you divide by, I hope you understand what I'm doing here. But if you divide by that y, which is the common denominator, and then divide by a y squared, it's the same thing as divided by y cubed. Now, the neat thing is we can back sub one more time, because look at this. I've got an x squared plus y squared, and what does that equal? Aha, it tells me right here it's equal to 1. So this final answer is pretty nice. Simplified. That makes me feel good, like I did something right. Let's see if the author did that. Yes, they did. Negative 1 over y cubed. So those are fun little back sub problems. There they go. He substituted that dy dx into that first derivative. He plugged that in. And then he plugged this in right here, that x plus y for this one that it was given. So that was a fun little problem, and you might want to continue practicing it. This is the same formula, the power rule that you've always known. I'll skip example 5. They're written explicitly. Remember, just do the chain rule. The derivative of the outside, write down, maybe it's difficult because I don't know why they throw this in here. This is old hat. Let's see, 2/3 minus 3/3 is negative 1/3. And then you just have to remember to take the derivative du of this x to the 6 plus 3x. I can't, you'll be fine. So it's worked out for you here on this next slide. Feel free to to work on that. I just wanted to see if there's one other thing that we haven't covered. I don't think you're going to have a problem with example 6 either. You just simply take the derivative of this thing and then plug in these points to find the slope. So, ooh, it looks a little complicated. I'm going to leave that for you. And then good, we're done. So maybe I can just work out one more problem. These look pretty good. Ooh, both of these look pretty good. You know what the deal is. I'm trying to get you to use the chain rule here and implicit differentiation at the same time. So you have to do the derivative of the outside or write down the inside times the derivative of the inside. But when you take the derivative of the inside, you're going to be doing implicit differentiation. So 13 is a great problem. And then likewise this, the derivative of e to the u is e to the u times, and then of course you've got to take the derivative of du. Oh my gosh, and this is going to be 2 y prime over here. But of course, to take the derivative of this, you're going to have to do the product rule. So these are just multiple steps that you're going to have to go through. There's the solutions for it. These are posted on Blackboard, of course. And then I would definitely practice 32. There's something similar to it on your test. Hint, hint. The answers to number 32 are right here. And I think 32 is more a couple back subs. So if you have questions, feel free to ask me. Thanks.